is Casey Schoenfeld, and this is kind of some notes for chapter 15. Oops. That is the weird section with no homework stuff. So definitely if you have questions, you got to let me know for sure since you don't have the book to look it up. You can probably Google some of the stuff for sure though. What we're going to do for 15.1 is functions and their representations. So functions, everything that we've really been dealing with is considered a function, but now we're going to like test things to make sure that they're functions. So some of the things, so I'm looking at the graph on, it's page ML-95, and I'll just kind of draw you the graph that they have given on the right-hand side of the top piece there. And the graph starts at up 3. So if I had to write the function, we could also do that because we wrote a lot of slopes. And then from there, it looks like it goes down to right 3. So then I'm going to repeat that a few times so that I can actually get this nice graph so that I can really tell what's going on with this line as well. So then I have, so let's pretend that I can draw straight lines and that this goes through that point and that point. So all the points that I actually drew. So this is a graph they have on the top of the page 15. Maybe you guys don't even have these yet, so I better draw a lot more stuff. So just a second. Okay, you don't have these. So anyway, you guys have to actually make sure you take lots of notes. So this graph is a graph that they'll tell you, and they want you to, like, some of the questions will be like, use graph. I will also email you guys these so you guys can print these off if you want to as well, this chapter 15 stuff. Use graph to evaluate, evaluate f of 0. And that's how it's written. It looks like f parentheses 0. It's definitely not f times 0, and f of 3. So what this is usually this f of 0, f of 3 looking stuff looks like f of x, and the number that we're looking for is going to be equal to the y. Okay, so also if we have f of x, anywhere you see it, we can write that as an equation instead of y. Okay, so then we also have, just from looking at this line, we don't even have to write an equation. We could write an equation in y equals mx plus b form. We know how to do that. I'll go over that in a few minutes. But right now, what they want us to look at is f of 0. What happens at the x value? Remember, this is an x value. So right here, this is our x value of 0. Okay, so at this f equals 0, what is the value of this graph? So all they want you to write is x equals 3. Okay, because that's what the y value is right there. Okay, the next thing it asks you is f of 3 equals what? So I go over to my x1 to 3, and I go up to wherever I hit the line. How high is this dot? The height is the y. So if my x is 3, my y is 1, because I'm up 1 unit off of the graph. Okay, so you'll be able to look at a graph anywhere to be able to tell that. And your guys' graphs, like, you can't really see the dot. You just really have the line in there with no dot. Okay, so I mean, you guys will just have to read the graph. Remember, x's, it's always like x comma y, and the x's are left, right. Left slash right. I'll throw a slash in there so you can tell I have 2 words. And the y is your up and down. Okay, so remember, left is negative, right is positive, up is positive, down is negative. Could have tried to write them in order for you guys. Then we do have to write some formulas as well. Okay, that was basically question 1 for the 15.1 lecture stuff. So then I'll go to question 2 as well. Oh, whoops, that's not the page I want. This is the button I want. So question 2, let me just kind of write it down. It says let function f. Function f just is a name of it. Function f, square the input. Sorry, I can't write in a straight line. Square the input x. Whoops. Input x. Then multiply. I'm just going to write multiply by negative 1/4. So you guys, if you guys already printed this off, or if you're looking at it side by side, you can do that and kind of read through that as well. So it says let the function f. So when it tells you this part with the input x right here, what that means is f of x. Usually I write it in cursive as long as you can kind of make it look scripty looking. That's kind of how your function notation is usually written. They're typed as pretty cursive-y looking f, so a little fancy. So function f of x means name the function x and the input is x. This is the input. Okay, that x right there. Whoops, I forgot to write it. Oh no, it says square the input. So the input is x. I'm squaring the input, and then I multiply by negative 1/4. Anytime we have the numbers, we usually write it out front. So negative 1/4 times x squared. Okay, so squaring the input is what that one's talking about. So that one's kind of weird for it. So that would have been A. So writing that formula or symbolic representation. This is that symbolic algebraic representation. A table of values is the next part that they tell us to do. Okay, so our table of values, they tell us what x's to plug in. So I have x's and y's. I'm going to do some different values. Or I'm going to do a different kind of table. I'm going to do like a vertical table so that I can show my work here too. So I have my x's that they tell me to plug in, which they use -4, -2, 0, 2, 4. Okay, and then I'm going to show my work in the middle, and then it'll spit out what my y is. Okay, so what this is if you kind of think about it, what this is going to look like is -1/4 times -4 squared. Okay, so you can kind of do this one in your head. It's not too much terrible work. What's squaring the input? So I have -4 times -4. That's what squaring the input means. Okay, so -4 times -4 is then equal to, I'm going to rewrite the 1/4 times a positive 16, because anything negative times itself is always going to be positive. Those are those negative and positive rules. And then 16 times 1/4, I can kind of treat it like a fraction, or I can do 16 divided by 4. 16 divided by 4 is 4, and then I have this negative and a positive, which makes a -4. Okay, so that's our first thing in our table of values. -2, I'm going to write out that same stuff. I write -2 in parentheses, squared. Okay, -2, I can rewrite as much if I want to. -2 times -2 is a +4. What's 1/4 of 4? It's just 1. Then I have a negative and a positive. That makes a negative. I have 0. I have -1/4 times 0 squared. 0 squared is 0. 0 times 1/4 is 0. Okay, 2, I have -1/4 times 2 squared. That gives me -1/4 times +4 again. So you should be getting the same answer. This pattern should start to repeat. You should find, I didn't mean to cross that out. Anytime I have this x squared dude that I have here, x squared, you should start to get some repeating things in all of our functions. Okay, I have -1/4 times 4 squared. It's going to be -1/4 times 16. 16 divided by 4, because that's all I'm doing when I'm multiplying by fractions. I'm taking whatever I divide by the bottom and multiply it by the top. So 16 divided by 4 is 4 times my numerator is 1, which is going to be -4 as well. I might have talked really fast. Sorry about that if I talked too fast. Okay, now we don't want to sketch this graph. Okay, in order to sketch these graphs, the easiest way that will always work, and I've told you this before, if you don't know how to graph something, make a table of values, everything that we just did. Right now, the only way you know how to graph these guys, this is called a quadratic function. Not everything that we're going to work with tonight is a quadratic function, but this x squared, anytime that we have anything other than just a plain old, we don't have any exponents that you see at all, we have this guy, which is called a quadratic function, or anything higher exponent that you normally wouldn't see. We have to make this table of values. Okay, I like to write out my points. So I have -4, -4. I didn't mean to make whatever symbol that was. Then I have -2, -1. Then I have 0, 0. Then I have 2, -1. And 4, -4. Okay, plot this, or to make this graph. Ooh, that was a really nice and lined up, and then that one's not lined up at all, sorry. Okay, I plot those points, so let's go left 4, down 4. That's the first point. So I go 1, 2, 3, 4, 1, 2, 3, 4. Make my dot. I plotted that point. Then I have negative 2, negative 1. I go left 2, down 1. Cross off that point. Then I have 0, 0. And then I have 2, negative 1. Over 2, right 2, down 1. I plotted that point. Then I have 4, negative 4. Over 4, down 4. Okay, this guy, it's really easy to just want to be like, let's draw some straight lines. But that is absolutely not what this graph looks like. So I just really need you guys to recognize if I have an x squared anything function, not that you can even see that, if I have x squared plus anything else, I don't even care what I have at the end, it needs to be kind of curvy looking. What we get, the shape of this graph, that one is not right. Okay, so always connect from left to right when we're doing that. So I'm going to do that, like connect left to right. Oh my gosh, my handwriting, I'm sorry. Connect left to right. All right, so that's that guy. So I started at my leftmost point, kind of made a curvy line, then a curvy line. So the only thing we're going to get straight lines for is when we had like those y equals mx plus b equations. Remember, I don't see any exponents right here on this x. Those are the only thing that I'm going to get straight lines for. So this part here, up here would be C. This would be my graphical representation. And then to determine whether something is a function, so the next thing is your question 3s are determine whether something's a function. What we can use even on this guy, whoops, sorry, I have lots of stuff open. Okay, I can, let me move all my stuff, sorry about that. I can make vertical lines. If I drew like an actual nice vertical line, like I'll draw some different graphs so you can see what I'm talking about, because this is kind of weird because this one, it does work out because it is a function. Okay, so to determine if something is a function, to see if function, we have what's called the vertical line test. When I'm doing the vertical line test, I have all these lines. On any one of these lines that I drew, oh, I keep doing it, sorry. Let me kind of try to drag myself. Okay, when I look back at this graph, as I drew each of these lines, does it cross the graph that I originally drew more than once? Try to think of like these like 20 different lines that I have drawn in here as one line. But this line, this line, this line, this line, each little single line only crossed once. Okay, so that's what vertical line test does. So the vertical line test means it's a function if it crosses once. And I'll show you one. Whoops, that was too many S's. Cross it. Okay, I put those in the wrong order. You can spell crosses. Crosses once. Not a function if it crosses more than once. Okay, so what that's going to look like is I'm going to sketch some of the graphs that they have. I'm going to kind of skip to 4, and then we'll go back to number 3. So on number 4, like just some of the graphs that they have drawn. Let me just draw a few of these little guys. Okay, some of the graphs is this U-shaped thing. That's a parabola as well that we just did. Okay, we do the vertical line test. Oh my gosh, that was not a vertical one. Ignore that one. Okay, vertical lines. Is it crossing that any more than once at any time, at point in time? Okay, I could draw them all the way up and down so you can kind of see the more verticalness. No, right here, it crossed once. Right here, it crossed once. Once. So this one would be, yes, it's a function. because it passed the vertical line test. That's kind of how you would say it. Then your next graph that they show you is a circle or like an oval or something like that. Okay, so to show you what the vertical line test means on this guy is I don't even have to do any more than once. Right here, it crossed twice. Okay, so this is not a function. I'm just going to write not fun, not fun. Okay, even though over here, I could have like theoretically drawn this and it would have only crossed once at this end. We don't care about that. When we do the vertical line test, we are looking for the place where it crosses twice. Does it cross twice? Yes, it is, so it's not a function. Okay, the next little graph they have on C is something that looks like this. What that is called is a hyperbola. That's how it's spelled. It's hyperbola. It's kind of spelled like hyperbole in English, but it's a hyperbola with an A instead of an E. Whoops, that wasn't a straight line. Okay, I only have to find one line. I can find tons of them, just like I could on this circle. I could find tons of them where it crossed twice. But I only need, right here it would have crossed once and once, so that would have been twice, and that one would have been twice. So that one's not a function. Okay, just some more. The next graph they have on D is a straight line. I can draw all the vertical lines I want to on that. It's never going to cross more than once for this straight line, except for I can't draw straight lines. Okay, so this is a function. Okay, this is my go-to test. This vertical line test is my go-to test for these guys. Okay, your next graph is what's called an absolute value function. We've graphed a few absolute value things, but not tons. Okay, so I'll just kind of graph this guy. Have to use straight lines. I'm not very good at actually using straight lines, so. Okay, did that one cross more than once? Did that one? Did that one? Can I find anywhere where it crosses more than once? No, I can't find anywhere. So this one is also a function. Okay, the last one they have on there. Sorry, that's kind of changing my colors up a little bit. Let me try to graph it. So hopefully you guys can look at this graph as well. It looks something like that. I have it a little more straight than they have it. They have, let me get my straight line. Okay, let me draw a different color. Did that one cross more than once? No. That one? No. That one? That one? Even though it gets really steep and it looks like it might eventually cross more than once, except for like my bad drawings, this one's really not going to. Okay, it's going to go left and right forever, and it's going to go up and down forever. So this one also is a function as well. Okay, so we'll also test some points to see if our points would make a function if you were just given our coordinate pairs. All right, and then to go back to like number 3 on that 15-1 stuff, what that looks like is the way that I still like to do it. There's a few larger, longer definitions of what makes a function with points, and we could go into a lot of those. Some of those are a little bit more confusing than just continuing to do this vertical line test. So I'm going to do 3a, and it gives me the point 1, 2. So I go right 1, up 2. 3, 4. So right 3, up 4. And over 11, I didn't make enough spaces. 1, 2, 4, 6, 8, 10, 11. And then I go up 10, 2, 4, 6. So we're going to pretend this is 10 up here. Okay, I don't have to draw a line. I'm not drawing a line. It's asking if this is a function. So what I do is I take my vertical line. I make this vertical line through each of these x values. Did that cross more than one point? No. Make this vertical line. Did this cross more than one point? No, it was just the one point on there. This guy, did that cross more than one point? Okay, I'm not talking about like the little dots that I made. I'm just talking about those 3 points that it gave me to actually graph. So it didn't cross more than once. So this function for like 3a is a function. So we would just have to write, is it a function? Yes, it's a function. Okay, I'm going to go ahead and I'm going to do Oops, I guess my next graph will be in red. Then I'll have to change more colors. Let me graph. Maybe this one, next one has 4 points, and I'm going to do 3C. And I'm going to do 1, 4. So over 1, up 4. Then I have negative 4, so that's left 4, up 6. 4, 6. And then I have 5, negative 1, so over 2, 4, 5, down 1 for negative 1. And negative 3, 4. So left 3, up 4. 2, 4. Okay. Again, we're not drawing any connecting dots on here. That's not what it asks us to do. I'm going to go in and I'm going to draw this almost vertical line. You're going to draw real vertical lines. Okay. Did that pass any more than 1 point? No. That guy, that guy, that guy. Nope. I don't need to check any other lines. I could make other vertical lines, but that doesn't help because those pass through 0 points. There are no points on this line at all. That's not helpful. I only really have to show it on these guys. And then this one would also be, yes, it's a function. And that was 3C. Yes, function. Okay, I'm going to do, I'm also going to show you on E, so 3E. And what that guy is going to look like is, if I had to write it all in points, or you can just use your table. You don't have to write all those things out. So what they give you is negative 8, negative 8, negative 8, negative 8. And then I have negative 3, negative 1, 3, and positive 4. Okay, so what they have here is if I draw my little graph, oh, I just keep forgetting to switch those colors back to normal. Okay, so I go negative 8. So, oops, I didn't change my pen. So negative 8 left for, oh, sorry, this is my x's and my y's. So I go negative 8, 2, 4, 6, 8, negative 3. Okay, that's that first point. Then I have negative 8, negative 1. That'd be that guy. Negative 8, 3. Negative 8, 4. This is what it's going to look like with points. When I draw that vertical line, does it go through more than 1 point? Right here it crossed 2. I don't even care what happened with these 3. Anytime it crosses just 2, that's enough to say this is not a function. Okay, so I want you guys, this is kind of like what the end of, oh, I'm lying, this isn't really the end of 15.1. I have to look on the second page for this 15.1 stuff. We're going to look at more of these guys. Also, on these graphs, I need to go backwards a little bit because we need to do what's called domain and range on these things as well. Okay, so I'm going to go back a few pages, so kind of hopefully you added some space so that you can do your notes in here. Okay, the domain for this guy, or wait just a second. Okay, we're not going to do the domain for this guy, so let me jump to, whoops, I need to go back some. Just a second, let me tell you where I was going to show you the domain and range on these guys, so we just have to do, decide what is our domain and range on everything that's a function, so we don't have to do that guy or that guy. Those are the only two that we had that were not functions. So our domain in this case, for the most part, everything that we're going to do tonight, I can't promise you the domain. I'm going to, after this point, I'll just do like D and R for domain and range. Domain is our x values, so it's our x's. What possible x's could we plug into this thing? So this is back to, this is 4a if you were able to look at it. The x's is how far left does this thing go? So if you kind of look at your graph, it kind of has some arrows on it. You can tell that the arrows are not actually pointing straight up. It's kind of hard to tell. But they're going to go left forever and right forever. So what that domain looks like, there's 2 ways to write it. And it's all real numbers. I'm just going to put a pound sign, all real numbers. Or negative infinity, because I can go to the left forever. Positive infinity, because I can go to the right forever. And we put those in parentheses. Okay, those are different notations. We'll get kind of familiar with the different notations in a bit. Okay, the range is how far up and down it can go. Those are my y values, so y's. So the ranges here, the range. How high does this thing go? Both my arrows point up on this guy, so we know it goes up, but how far down can it go? we can pretty well count to right where it is. And if you're actually looking at your graph on 4a, it is not quite the same graph, but I will just make it, this is 1 and this is -2, so that's -1. So our range, it goes all y's that are bigger than or equal to -2, because it does not get less than -2. Okay, so this is one way to write it. The second way to write it would look like, what's my lowest number? My lowest number is -2. Can it equal -2? If you looked at your graph, you would say, yeah, it probably equals -2. And I have this square bracket. How far does it go? It goes up forever. So I go up is positive infinity. Okay, so I will talk more about this in a little bit. This is called your interval notation again. This is an easy version of set notation that I'm being a little bit lazy with. I like interval notation a lot more. Okay, you learn a lot more about interval notations when you get into college algebra, but right now you still kind of need to be able to read some of them. Okay. D, your domain for this guy. So D for domain. Domain, how far left does this straight line go? And this one is 3D. 4D, I'm sorry, 4D. Okay, how far left and right does this guy go? Left, it goes to -infinity. It goes forever left. How far to the right does it go? It goes to positive infinity. That would be my interval notation. The other notation would be, you could just say all real numbers. All reals. We call reals real number. The other way to write reals, remember we kind of did the fancy scripty R. Okay, our range. Range is how far up and down does it go? How far does this go down? We always talk about down to up or left to right. Okay, down, it goes down forever, so also -infinity, not -8, -infinity. Positive forever, infinity. Also all reals. I'm just writing my fancy R for all reals. Okay. This guy, this next one, so I can scroll down a little bit I didn't want to scroll down that much, sorry. Okay, the domain for this guy. Remember I told you this was an absolute value? What this looks like is domain. How far left is this going to go? It's going to go forever. How far right is it going to go? Forever. So we can say all reals. So just the fancy R. I kind of forgot what I was writing. Or we can say since it goes left forever, that goes to -infinity. Since it goes right to forever, it goes to positive infinity. Okay, that's your interval notation. Anytime you try to write something in interval notation, your infinities always have a parenthesis instead of a bracket, which is kind of weird because you haven't really learned a lot about that yet. And you should get into it a little bit more in college algebra. That's what I get to tell you. Range, not a fancy R, just a regular R. Range, how far up does it go? Or we always talk about down to up, so how far down does it go? We can see this is the lowest y value it has. Okay, that y value is 0. So back, I'm going into my interval notation. Because it does hit 0, it gets a square bracket. You can plug in 0 into an absolute value. Okay, and then you have to positive infinity because it goes up forever. Okay, not even that would be like the part of the graph, but you can see that these guys go up. Range, or also what this would look like is y is greater than or equal to 0. Okay, this guy, it goes down forever, it goes left forever. It goes up and right forever. So your domain and range, domain is all reals, range is all reals. Whoops, I kind of forgot to write all there. Okay, what that looks like in this interval notation is -infinity to infinity, -infinity to infinity. You don't have to write it both ways whatsoever. Just get used to being able to tell me what the domain and the range are. Okay, then when I got to these points, okay, I'm just going to talk about 3a and 3c. I'm not going to talk about much else. The domain here, I'm going to erase this really squiggly line that keeps bugging me. Okay, so I'm looking back at the values. After we determined it was a function, we would write the domain is colon And then we have, this is our Bob Hope profile that I'm trying to, a squiggle face, a squiggle bracket, I'm sorry. And then we write all our x values. So our x values were 1, 3, and 11. Okay, this is 1, this is 3, this is 11. Whoops, should be a squiggle bracket at the end too. Or just a funny looking bird, whatever you want to draw. Okay, your range, this is the only way to write this. We don't get interval notation for this guy. We get just the squiggle brackets. The squiggle brackets are what's called set notation. Okay, just S-E-T. The range is the y value. So that y is 2. That y is 4. And this guy up here, if we remember, we have to look back at my points that we were given, is 10. Okay, so this is what your domain and range should look like for these guys. Okay, whoops, so let me go to the next page. So here, if you just looked at it, you can just real fast write them down from whatever they were given. After you decide that it's a function, you just have 1. Oh, and then this is something else. You have to write them in least to greatest order. So it should be -4, -3, 1, and 5 for your x's. Okay, it's easy to do when you're reading them left to right. It's harder to do like I was just doing, and I was looking at the paper and reading them in the order they were given, not in the order that I should have. Range, I read top to bottom to top, I'm sorry. So I have -1 is my lowest. What's my next lowest? Oh, these are at the same. So since those are at the same, they're both at 4, and I only write it once. Okay, so I talked about I have this range, and this in my range, which is 6. What is it, 6? Yep, 6. Okay, even though I have 4 points, I only have to write 3 of them because we don't repeat things in our range. Then the next page that we hear, we can't do domain and range because it's not a function. Okay, so there's more things that you're doing, domain and range. Then let's go into number 5 on this back page. Number 5 looks, I'll do 5a first of all. So 5a looks like f of x equals 4x plus 9. Okay, something to make it a little bit easier for you. Think about this still, is y equals 4x plus 9. It's the same thing. If you guys want to look, we can look at a graph. Graphs are nice to look at. Okay, and if you have your graphing calculator, you can go push your y equals button on the top left-hand side, and you can type in 4x plus 9. The way you get to your x button, in case you want to know, it looks like an xt theta n, something like that. That's where you type in your x's if you need help remembering those guys. 4x plus 9, we know how to graph that. We go up 9. I'm going to count by 2s. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is my b, which is where I cross there. Okay, my slope is 4. I can't count up. I know I'm going to have something that goes up because it's a positive slope. This is a positive 4. But then I can go down 4 and left 1. So I can go down 4, left 1, down 4, left 1. Okay, so then I should be able to draw this line. Whoops, I didn't get my straight line tool like I wanted to. Okay, so hopefully you should have a line that looks something along those lines. Okay, if you had to look at the graph, you don't have to look at the graph. Okay, how far left and right does this go? Okay, so I have to do my domain and range for these. I don't even have to graph it. So my domain, it goes left forever. That's negative infinity. That's a negative sign. It goes right forever. It's a positive infinity. My range, how far down does it go? It goes to negative infinity. How far up does it go? It goes to positive infinity. All right, so that's what you're doing for domain and range. The other way to think about it, if I just looked, let's just kind of try to ignore this now. Don't cross it off on your own paper. Equals 4x plus 9. All right, so the way that we kind of need to talk through this is our domains are our inputs. Is there anything that we cannot multiply by 4 and add 9? Okay, even if we did 100 million. 100 million times 4, can we do that? Can we add 9? Yeah, so that's where we get the domain. Domain is what we plug in. What can you plug into that? The range. The range is what can you get out? Can you get out any number? If I want to get out 100 million, if I set that equal to 4x plus 9, can I solve this equation? Yeah, I can get anything I want out of that. And that's what range is. So domain is what you plug in, range is what you get out. All right, so let's try to kind of talk through the next one, which is going to be a little bit different than just all real numbers, but we'll see kind of how those will change. Okay, so I'm just going to pick out a different color. So 5b asks us, what is the domain and range of f of x equals x squared minus 3? Okay, is there anything I cannot plug into this? Can I square every single number? Can I square negative numbers? Can I square positive numbers? Can I square pies? Yeah, I just get pi squared. It'd be 3.1 times 3.14. Yeah, you got it. 3.14, 3.14. You'd keep going for a long time, but you could get as much as you could find out about pi itself. Okay, so I can plug in anything. Okay, I couldn't find anything that I couldn't plug in. So these ones that we're doing are usually going to be pretty nice, that we can usually get out about every number that we can plug in about any number. So that's going to look like negative infinity to infinity, because I can plug in anything between negative infinity all the way up to positive infinity. The range. The range is where we kind of need to pick out a few different numbers. Can I get anything? If I said I want to do a negative 100, let's just kind of pick something easier than a little bit 100 million. Negative 100 equals x squared minus 3. Okay, so try to maybe, like, if you're doing these things, pick out negative and positive, and so you can kind of narrow it down. Also, what you can definitely do is you can plot points to graph this guy so you can look at it a little bit more visually. Okay, because I'm doing this a little bit more thought-wise instead of let's actually look at the math. Okay, so negative 103. Can I take the square root? Because that's how I'd have to undo the x squared. I'd have to take the square root. Can I take the square root of negative 103? Forget the fact that I don't know what the heck the square root of 103 is. Can I take the square root of a negative number? Because square roots, when I'm talking about square roots, I'm talking about what two numbers times itself equals negative 103. Okay, what do we know? That's really what I'm asking right here. What two numbers do I have to find? Do I have to multiply by? Okay, first of all, to get a negative sign. Okay, remember your multiplication rules. They say a negative times a positive equals a negative. Can I do a negative times a negative? No, because that also gets me a positive. Can I do a positive times a positive? No, that gets me a positive as well. So the only way that I can get this negative 103 is if I had one positive number and one negative number. If they have to be positive and negative, that can't happen. I can't have anything negative. So that's what's going to happen every time I do square roots, is I can't take negative square roots if I had to solve this guy. So what happens is we end up not being able to plug in a couple numbers, but then it's kind of hard to think about it this way. What numbers could I finally plug in? Okay, so that's what kind of gets weird. Okay, the smallest number that I can take a square root of when I had to solve this guy would be 0. So I'm still talking you guys through this. I'm sorry, this is kind of, if I'm getting a little bit weird here. Okay, if I just talking about this x squared minus 3, and I don't know what I have over here yet, but what could I add 3 to? What's the smallest number I could have over here? So if I just solve this, because I want it to equal 0. Okay, I'm going to stop what I'm doing because I think I'm going to make it more confusing. Okay, let's plot some points and graph it. We can always do that. I told you that we've always been able to do that, so let's just kind of go back to what we always know how to do. So I paused it there for a second in case you guys are wondering. I'm going to make an XY table. Okay, X and Y's. anytime I do my x's and y's, so I know I have x squared minus 3. I'm going to plug in like -2, -1, not -1, just -1, 0, 1, 2. Those are the numbers I'm going to always try to start with. And remember, this is an x squared. I want something that's kind of U-shaped. Okay, I can't draw a U. Okay, U-shaped, that parabola. Looks like parabola. Not like Ebola, though. Okay, so I do -2 squared. What's -2 times -2? Okay, that's +4. +4 minus 3 gives me -1. +1, sorry. You guys are thinking I'm crazy. So it gives me +1. Okay, -1 squared. We're squaring things first, and then we're subtracting 3. -1 times -1. Okay, that gets me +1. +1 minus 3 gets me -2. 0, 0 squared, that's a nice one. 0 squared is 0. Minus 3 is -3. 1 squared, I should start seeing this pattern here. 1 times 1, 1 squared is 1. Minus 3 is -2. 2, 2 squared is 4. Minus 3 is 1. Let's go over and plot these points. So -2, I'm up 1. At -1, I'm down 2. At 0, excuse me, I'm down 3. At right 1, I'm down 2. At right 2, or at right 2, yes, I'm up 1. Okay, remember I should get this U-shaped thing. Wow, that was not a U-shaped thing. Okay, again, I can't draw U's. Hopefully you got the point of that. Okay, so what you're doing is, what is this lowest number that can go in here? Okay, what is my range? What's the lowest my range gets to? Okay, it's 3. Whoops, my low always goes on my left, so I have 3 for my range. How high does this guy go? I can find the square root of anything else positive. It doesn't matter if it's like 100 million infinity. I can find those square roots. Okay, so that will give me to positive infinity. Okay, so this is just kind of, I'm going to give you guys some notes. I'm going to give you guys just a few things to remember domain and range by. So if it's linear, whoops, I forgot an A. Linear is going to look like your y equals mx plus b. Remember, y, I could exchange this y for f of x, all the same thing. Okay, it's just f of x means I'm using a function notation, and that's what this guy's about. For linear stuff, so it's some number x plus or minus some b. Okay, so what that guy is going to do is he's going to have a domain of -infinity to infinity. He's going to have a range of -infinity to infinity. Okay, this is not only going to be true for linear functions, it's going to be true for any what we call odd functions. That could be like an x cubed, x to the 5th, and it doesn't matter what's over here, plus, 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 plus. It could be like a 10x to the 5th. Okay, odd functions with odd powers. Odd, all right, with odd exponents. Okay, and you'll learn more about those when you get to college algebra. I just really want you to kind of remember it now. So this is what your domain will look like for all of these guys. Okay. Then we've done a couple quadratic ones. Quadratics look like the generic way to write it is ax squared plus bx plus c. It's just something with an x squared. We don't care what's on the end. X squared is the highest value. I'm going to write f of x right here. I'm going to write y equals down here just so you see that they're the same. They're not any difference. They're totally interchangeable there. It could have some number in front of that x squared. That doesn't matter. Quadratics always have a high or a low. Okay, this is nice. Do your xy table. Xy's. Okay, they're either going to look like this or like this. Okay, your domain for both of them. So I will talk about the range right here and then domain. Here, okay, I'm changing my mind in the middle of what I'm saying. I'm sorry. Domain is we can plug in any number. We can square any number that we want to. The range is what's going to be different. The range On this guy that opens up, okay, so this guy goes up, it has a minimum. It's the low, sorry, it should have a square bracket, so it's a low to infinity. The high here, it's going to look like, it goes down, not up. So what that guy's going to look like is negative infinity to the high, is what I'm going to write. And that also has a square bracket on that high number. Okay, something else you also saw a little bit of was what was called absolute value functions. So 5e is an absolute value. And what that looks like is f of x equals the absolute value of some x value. Okay, what this is always going to look like, also go ahead and plot your points on this guy too. So plot points, I'm just going to write a note, because you're either going to have something that looks like this V-shaped thing or this V-shaped thing. Okay, your domain for these guys will be kind of the same as it was for your quadratics, that x squared dude. I have negative infinity to infinity. Okay, your pick a different color again. My range, this is my high. It will be, if it looked like this guy, it would be negative infinity to the high. This guy's going to be the opposite, which would be square bracket. I keep forgetting my square brackets. Low to positive infinity. Infinities always have a parenthesis. Your highs and lows will usually have a square bracket. Okay, and they will on absolute values. They always will on absolute values. I'm sorry to say usually and then try to change my mind. Now I'm going to go through and I'm going to kind of try to do this so that you guys can all fit it on one sheet of paper. What we have is 5D, and I want you, I'm going to give it to you, it's f of x equals the square root of x plus 2. And what that guy looks like is, let's plot some points for this too. Okay, make an xy table. And I plug in -2. So if I did -2, what's the square root of -2? Crap, I can't find square roots of negative numbers. Okay, I can't plug in -2. Can I plug in -1? What's the square root of -1? I can't do that one either. Okay, let me just write that one out on why it doesn't work. Plus 2 is it's this guy right here that I can't find. Okay, so let's plug in 0. What is the square root of 0 plus 2? I'll just make a new table. That's 2. How about 1? I'm gonna lose some room. Okay, what's the square root of 1 plus 2? That's 3. Yay, we can do that one. Okay, let's try to pick some numbers that I can take square roots of. I could take the square root of 0, I could take the square root of 1. Can I take the square root of 2, 3, 4? I can finally. Okay, 4. What's the square root of 4 plus 2? It's 2 plus 2, that's 4. Okay, I'm going to try to use some more room. What's the next number I can take the square root of? Is it 5, 6, 7, 8? You can finally take the square root of 9. So what's the square root of 9 plus 2? 3 plus 2 is 5. Okay, let's go through and plot those points. Okay, this looks like it's going up really nicely, but those numbers didn't go up really nicely. So it's going to look a little bit different. It's kind of, we expect it to be a straight line just from the fact that we got these answers, but remember that we picked different answers. I couldn't plug in anything negative, so I don't have anything over here at all. Okay, I'm going to erase that. 0, 2. So over 0, up 2. Okay, so let me kind of count those. Then over 1, up 3. Sorry that my scales is not matching up very well. Over 4, so 1, 2, 3, 4, up 4. Oh, so that one worked out pretty cool. We're going to call that 4. Somewhere in there is 4. Then I have over 9, so that was 4, 5, 6, 7, 8, 9, and that went up to 5, not 15. It looks like a 15, I'm sorry. Okay, so it went up another one. So what these graphs are always going to look like And I can't say always, you need to plot these points. Okay. You could have like basically 4 graphs. Hopefully you guys won't have anything that looks that gross. You can have like that, 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 or that. None of them are going to be together because remember that wouldn't make a function. Okay, really just plot these points. I'm not going to give you any rules because there's so many different ones of these guys. But remember, like my domain, what x's can I plug in? Oh, there was x's that we couldn't plug in. We couldn't plug in negatives here. So my domain here was from 0 because I could plug in 0, and it goes to the right forever. I'm looking at that graph. It goes from 0, right. My range, sorry that my D's don't hardly look like D's. My range, how high did it start? What was the lowest number it started with? Here it started at 2. Did I actually get out 2? Yeah, okay, I actually got out 2, so that gets to go in for my range. And it gets a square bracket because of that 2. Does it go up or down forever? This one goes up, so it goes to positive infinity. Okay, so really just get better at looking at those graphs. Try to work on those things. Really let me know if you guys need help, you guys.